I'm Katie Laird from De Montfort University. I'm head of the Infectious Disease Research Group, and my research is centred on domestic laundering of healthcare uniforms. So what I'm going to talk to you about in this presentation is what the current policies are they adhered to? We did a survey across 265 nurses, what the effect of low temperature laundering is on the microorganisms, and what evidence there is to support home laundering, and is it safe to launder your nurses' uniforms at home. This is currently the Department of Health's policy on domestic laundering of nurses' uniforms, and the key data here is that uniforms should be washed at 60 degrees Celsius for 10 minutes. However, if uniforms are washed at a lower temperature, as low as 30, the policy says that it will eliminate most MRSA and other microorganisms. The other key points in this policy are that uniforms should be covered when nurses are going home to and from work, and also that there should be no visible soiling present on the uniforms. This work was conducted or compiled by some research done at UCL and 2 literature reviews. So, as I said, the uniforms, if they're washed at 30, the policy says that most gram-positive organisms will be removed, and that washing at 60 degrees Celsius will remove 0.1% of Clostridium difficile and its spores. And the evidence base, as I said, was 2 literature reviews and the practical work at University College London. So what we did was wanted to find out exactly what the nurses were doing with their home laundering and how they were washing their uniforms. So we carried out a survey in which we got 265 responses. We did it across 4 hospitals in 3 different counties. Now, to ensure that we were getting a balanced view of where the data was coming from, we split it into infectious disease wards and non-infectious disease wards to see if there was more education around infection control in those infectious disease wards, and if that impacted on the way in which nurses laundered their uniforms. We then looked at the policies that each trust was passing on to their nurses. So the information is disseminated from the Department of Health through the trusts. And the first thing we found was that there was quite varied information being given to the nurses. If you look at this table, the Hospital 3 here has put a minimum of 50 degrees Celsius. When we look at detergent, there's no requirement in Hospitals 1, 3 and 4, and the frequency of change of uniforms in Hospital 2, there is no requirement, and the wash load of the domestic machine, again, no requirement in 2 of the hospitals. The other 2 do state that the uniforms should be washed separately. So from the surveys, once we'd analysed the data, what we were seeing was that there was a peak of nurses washing their uniforms at the 60 that's stated by the Department of Health. So overall, that was about 45% of nurses. But what we also found was there was another large peak at the 40 degrees, where we were getting sort of 35% of nurses washing at 40 degrees, which is below the recommended 60 of the Department of Health. We also had a few, worryingly, that were hand washing. So we also wanted to understand how they were laundering. Was this just the uniforms being laundered on their own, or were they being laundered with other items of clothing? And again, we found there was quite variation. Between 55 and 60% were washing alone, which was great, but the others, around 40%, were washing with other items of clothing. So now we knew how the nurses were washing their uniforms. We want to establish if this had any cross-contamination risk. So the first thing we needed to know was how long do microorganisms survive on just fibres of cotton and polyester, which are the most commonly used in nurses' uniforms. We chose two microorganisms. We chose a gram-negative and a gram-positive. So we chose E. coli and Staphylococcus aureus, which is obviously the non-resistant strain of MRSA. As you can see from this graph, that the microorganisms survived better on cotton. You would expect this. There's more moisture availability, potential nutrients availability in comparison to the man-made fibre of polyester. But you are seeing from a sort of 10 to the 8 initial load that 10 to the 6 microorganisms are surviving up to 21 days on the polyester. On the cotton, on the polyester, this is much shorter. We're looking around 7 days survival of the microorganisms. We then took the most commonly used laundering parameters that nurses had said they used in the questionnaire, and we took that into the lab and looked at what was happening under those conditions. We took some polycotton fibres and textile swatches, and we put 10 to the 8 of, so quite a high load of E. coli, and on a separate piece Staphylococcus aureus. We washed them separately so we didn't cross-contaminate them. And what we found at 40 degrees was that both the 100% polyester and the polycotton, there was around 4.5 logs, so that's around 1,000 cells, surviving on the textiles. This was across both types of fabrics, and what we also found was that around 1,000 cells were also transferred onto sterile textiles that were also put in the wash. So not only were the microorganisms surviving, they were being transferred onto other items in the wash as well. Now, if we talk about this in terms of percentage, it is a high percentage reduction, but it's the potential risks that the cells remaining on the textile could pose. Now, if the uniforms are washed at 60 degrees, we did exactly the same experiment at the 60 degrees Celsius, which was what the Department of Health recommend. We did find, to our detection limit, that all of the bacteria was removed and that there was no cross-contamination. So this does agree with the Department of Health policy. The issue around this is that it may not be being followed, and we don't truly understand the potential risk there is from that remaining bacteria. We also then wanted to look at the effect of detergents. We had looked at biological detergent when we did the wash test, which was the most commonly used ones from our surveys. And what we did was we took the industrial standard of 71 degrees, 60 degrees, which is the Department of Health temperature, and then the 40 degrees, which is what roughly 40% of the nurses are using. And we tried a range of different detergents. So the control here was just water alone, so we were looking at the effect of temperature only. We chose biological, non-biological, halo, which is a low temperature antimicrobial detergent, and then we use the standard ECE, which is used in textile testing. And what we found was this wasn't in a washing machine, it was just static. So we'd taken away the dilution factor and we'd taken away the agitation of the machine. We just wanted to establish what temperature and how temperature and detergents were behaving on the microorganisms. And what we found is there was a considerable amount of microorganism remaining when the temperature started to be reduced, both for E. coli and not as much in Staphylococcus aureus. what we're looking at here is hurdle technology. So detergent does need to be used with temperature. So when we're looking at the Trust's different policies and there's no requirement for detergent, there is the potential to say there should be a requirement for detergent within that. And then obviously when we get the dilution factor and we get the agitation, that will increase the reductions. We also, so the cells we were looking at with E. coli and Staphylococcus aureus were the vegetative cells, but microorganisms like C. difficile produce spores, which are much harder to destroy. So another area we wanted to look at was what was happening with those spores and removal of the spores with temperature and detergent combinations. As you can see from here, we looked at 71 degrees, which is the industry standard. We looked at 90, which is above that, and then we looked at a room temperature, because if there's known C. difficile spores on a uniform, so it's come out of a C. difficile ward, these should be industrially laundered. And what we really find in here, this was the exposure to the reference detergents, so a detergent we know that works is that when we added 10 to the 6 here at 90, we got a considerable amount of reduction. However, when you started to lower the temperatures to 71 and 25, again, there were still spores remaining. So, C. difficile spore at 25, the detergent didn't exhibit any antimicrobial effect. At 71 for 20 minutes, we were only getting a less than 1 log reduction, and this would leave 2.5 logs of viable spore counts there. This needs further work. We need to look at it in the wash setting, but this gives an indication of, again, that hurdle technology of temperature and detergent being key to the removal of the spores. So, looking at this research, what can we gain from it? Well, firstly, we need to consider that it's only in vitro data. It's only data that's been collected in the lab, and that we need to find this data from a real life setting, so naturally contaminated uniforms, and looking at how they perform from different wash temperatures and detergents. We did test with high loads. We were looking at absolute worst case scenarios. The investigation were only with type strains. We need to look at clinical isolates and antibiotic resistant isolates. The other thing we didn't consider, because there was so much variation across the surveys, is the different drying practices. So this varied from tumble dryers to radiators to letting things dry out on the line. So this may have some effect due to desiccation on the cells. And the other thing we would say is we know that textiles are a carrier of microorganisms because the above the elbow policy was brought in, so that there was no textiles in contact with the patient. So what is safe procedure? What is the Department of Health policy showing? Where do risks need to be assessed? First of all, uniforms should be changed after every shift, because if any microorganisms are being picked up, we know they survive on polyester for up to 21 days and cotton for 7 days. Uniforms should be washed immediately for the same reasons. They should be stored separately from any other textiles in the home, because those cells are still viable that have come in with the uniform and could be transferred to other surfaces. They should be washed separately from any other clothing, especially if nurses are going to wash at lower temperatures, because we've shown that the contamination can be passed on to other sterile textiles, and it definitely should be washed at 60 degrees Celsius for a minimum of 10 minutes. So who I'd like to thank for this, I'd like to thank our collaborators, the hospitals that took part in the survey, and all the healthcare staff involved. We've had a range of PhD students working on these projects, including Kate Riley, Joanna Tarrant and Lucy Owen. We'd also like to thank the Society for Applied Microbiology for funding some of the fees for Kate Riley. Okay, thank you.